This is Tech and Politics, and my name is Andreas Jungherr. Welcome back to the podcast accompanying the lecture series Digital Media in Politics and Society at the University of Bamberg. In this episode, we will be talking about another typical approach in computational social science. As we have seen, in computational social science, there are great hopes and enthusiasms connected with the availability of new data sources. Particularly, one new data source features in these accounts: digital trace data. Once people interact with digital devices, such as smartphones and smart devices, and services, such as Facebook or Twitter, the digitally mediated interactions leave traces on devices and services. Some of those are discarded, some are stored. Some are available only to the device maker or service provider, some are available to researchers. This last category of digital trace data, those that are stored and available to researchers, has spawned a lot of research activity and enthusiasm over a new measurement revolution in the social sciences. But somewhat more than 10 years into this revolution, the limits of digital trace data for social science research are becoming just as clear as their promises. Before we look at studies using digital trace data, it is therefore necessary that we look a little more closely at what they are, what characteristics they share, and how this impacts scientific work with them. In the 2011 article, Validity Issues in the Use of Social Network Analysis with Digital Trace Data, James Howson, Andrea Wiggins, and Kevin Croston define digital trace data as, and I quote, records of activity, trace data, undertaken through an online information system, thus digital. A trace is a mark left as a sign of passage. It is recorded evidence that something has occurred in the past. For trace data, the system acts as a data collection tool, providing both advantages and limitations. The task for using this evidence in network analysis is to turn these recorded traces of activity into measures of theoretically interesting constructs. End quote. Now, replace the term network analysis in the last sentence with social science, and you have the crucial task in working with digital trace data before you. This translation of traces into theoretically interesting constructs demands for accounting for specific characteristics of digital trace data. Back to Howson and colleagues. And I quote, first, it is found data, rather than produced for research. Second, it is event-based data, rather than summary data. And third, as events occur over a period of time, it is longitudinal data. In each aspect, such data contrasts with data traditionally collected through social network surveys and interviews. End quote. Again, replace social network with social science and you're good to go. It is probably best you go find the article and read this section of the text yourself. But let me briefly explicate the concerns expressed by Howson and colleagues as they relate to social science more general. First, digital trace data are found data. This makes them different from data specifically designed for research purposes. Usually, social scientists approach a question through a research design specifically developed to answer it. You're interested what people think about politicians? You ask them. You're interested in how a news article shifts opinions? You design an experiment in which you expose some people to the article, but not others, and later ask both groups for their opinion on the issue discussed in the article. With digital trace data, you do not have that luxury. Instead, you often start from the data and try to connect it back to your interests. What do people think about a politician? Well, maybe look on Twitter and count her mentions. If you really get fancy, maybe run the messages through a sentiment detection method and count the mentions identified as positive and those identified as negative. Want to identify the effects of a news article? Check if people's traces change after exposure. Already these two examples show that found data can be used in an interesting way. At the same time, you often have to compromise in working with them. Thinking purely from the perspectives of research design and identification approach, digital trace data will often leave you frustrated, as they simply might not cover what you need. On the other hand, once you accommodate yourself with what signals are available to you in found data, you might land on new questions and insights that, following a purely deductive approach, you might have missed. This is especially true for questions regarding the behavior of users in digital communication environments or the inner workings of said environments. Second, digital trace data are event data. They document interactions and behavior in collections of single instances. Like a Facebook page, write an ad message on Twitter, comment on a post on Reddit, edit a Wikipedia page, click on a site, on and on. These events can carry a lot of information. For example, measuring the impact of an ad through clicks of featured links is a perfectly good approach. But in social science, we often are interested not only in specific interaction or behavior events. Instead, we ask for the reasons underlying these events, such as attitudes or psychological traits. To get at these, we need to understand how users interpret the action that led to a data trace. Take one of the examples from earlier. If we want to understand public opinion on a politician or a political topic, researchers often look for mentions of an actor or topic in digital trace data. But the motives for mentioning a politician or topic on a digital service vary. One could express support, critique, neutrally point to a topically connected event or quote, or one could try and be funny in front of friends and imagined audiences. Some of these motifs might be identifiable by linguistic features around the term. Others might not. In connecting the event visible in digital trace data, mentions of actors or topics, with the concept of interest, attitudes towards them, means taking into account the data-generating process linking the documented event to the concept of interest. This step is crucial in the work with digital trace data, but often neglected in favor of a naive positivism, de facto positing that digital traces do not lie and speak to everything we happen to be interested in. Third, Hausen and colleagues point to digital traces demanding for a longitudinal perspective. Data documenting singular events need to be aggregated in order to speak for a larger phenomenon of interest. But what aggregation rule is appropriate or not? That is open to question. For example, many sociologists are interested in the effects of friendship relations between people. Friendship is an interpretively demanding concept. This raises many measurement problems. Some people interact with people they consider friends often, others interact with people they consider friends only seldom, but hold deep affection and trust. Just looking at interactions in person, on the phone, or online will therefore not necessarily tell us who the people are our subjects consider friends. Traditionally, sociologists would survey people to identify people they themselves identify as friends. They therefore have access to the result of the personal calculus of respondents over all interactions and experiences with the person, resulting in their assessment of the person as friend or not. Simply looking at digital trace data, as for example email exchanges, public interactions on Twitter, or co-presence in space measured by mobile phones or sensors, only provide us with single slices of this calculus, leaving us to guess the aggregation rule translating single events visible in digital trace data into the latent concept of interest. This is true for social relationships, as friendship, but also for other concepts of interest, such as attitudes or traits. Researchers need to be very careful and transparent in how they choose to aggregate the events visible to them in digital trace data and take them as expression of their concept of interest, especially if it's an interpretively demanding concept. Finally, Hausen and colleagues emphasize that digital trace data are, and I quote, both produced through and stored by an information system, end quote. This is important to remember. It means that both the recording of the data as well as access to it, depend on the workings of said information system and the organization running it. For one, this means that it is important to differentiate between social and individual factors contributing to an event documented in a data trace and features of the underlying information system. An example for an individual factor leading to a data trace could be my support for a given candidate that makes me favorite a tweet posted on a Twitter feed. Alternatively, a system-level feature could be an algorithm showing me a tweet by said candidate prominently in my Twitter feed, in reaction to which I favorited in order to read it later. These are two different data-generating processes driven by different motifs, but not discernible by simply looking at the digital trace of the event. The second consequence of the prominent mediating role of the information system is the dependence of its internal reasons for recording and providing access to data traces. Researchers depend on information systems and their providers in providing them with access and setting access rules. This can be comparatively rich, as currently is the case with Twitter, or comparatively sparse, is the case with Facebook. In any case, shifts in access possibilities and rules are always possible and do not need to follow coherent strategies. This makes research highly dependent on the organizations collecting and providing access to data and introduces a highly troubling set of concerns regarding ethics of data access, conflicts of interest between researchers, organizations, and users, and transparency and replicability of research findings. While these challenges persist in the work with digital trace data, this new data type has found a prominent place in social and political science. Unfortunately, the degree to which these challenges are reflected in actual research varies considerably. Nevertheless, let's take a closer look. Digital media have led to far-reaching changes in social life and human behavior. These new phenomena lead to new research questions which digital trace data have been used to address. Areas in political science that have seen the strongest impact of digital media, and therefore research using digital trace data, include the practice of politics, political communication, structures and dynamics in the public arena, and discourses. Various studies using digital trace data focusing on politics and political communication have addressed the behavior of political elites, partisans, and the public. This includes the use of digital media in political campaigns, protests, or the coordination of citizens and civil society. Other studies examine structures of the public arena, media use, and discourses in digital communication environments. This can be, for example, investigating how people use the media. While the traditional approach would exclusively ask people in surveys for their media usage patterns, digital trace data offer powerful additional perspectives through greater reliability and greater resolution. An example for this are web tracking data that track and document website visits by respondents. In addition to new perspectives on the use of news sources, digital trace data also offer new perspectives on the influence of different media types and sources. Here, examining agendas of the most important issues in different digital and traditional media and their mutual influence dynamics are promising research areas. More specific to digital media still are studies focusing on usage dynamics and behavioral patterns of people in their use of digital services. This focus area lends itself especially well for the study through digital trace data. Examples include studies focusing on Facebook, Reddit, Twitter, or YouTube. Beyond the study of commercial services, digital trace data have also been successfully used in studying the behavior of people on e-government sites, such as online petitions. Other studies are using digital trace data to examine the ways governments react to the challenge of digital media. In particular, authoritarian states see themselves increasingly challenged in their control of the public by digital media and the associated new possibilities for information and coordination of their population. Digital trace data have provided researchers with promising instruments for documenting and examining digital media provision and attempts at government control in different countries. Beyond the study of phenomena directly given rise by the use of digital devices and services, researchers are also trying to infer general phenomena based on signals and digital trace data. Examples include the estimation of political alignments of social media users or the prediction of public opinion or election results. While often original and sophisticated in the use of methods, the validity of resulting findings is often contested, since they often risk misattributing meaning to spurious correlations between digital traces and larger societal phenomena. Now, this was a long list of topics and potential research questions. For a list of studies pursuing these questions, make sure to check the script to this episode on the website. There, you'll find detailed source information and links to studies addressing the topics listed here. But now, let's look at two studies a little more closely to get a better sense of how work with digital trace data actually looks. The most direct way to use digital trace data is to learn about the digital communication environment they were collected in. But before your eyes glaze over now in expectation of another starry-eyed discussion of hashtag trends on Twitter, there's more to this than the good, the bad, and the ugly of social media. For example, looking at what happens on digital media can tell us a lot about how states regulate speech or try to control their public. One important example for this is, of course, China. By now, there are a number of highly creative and instructive studies available that use data collected on digital media to understand the degree, intensity, and determinants of Chinese censorship activity. In their 2020 paper, Specificity, Conflict, and Focal Point, a systematic investigation into social media censorship in China, the authors Yun Tai and Qinghua Fu examine censorship mechanisms on WeChat. WeChat is an important social media platform in China, which in 2019 was reported to have more than 1.1 billion monthly active users. It is an umbrella application that bundles many different functions for which Western users would have to use different applications. For example, WeChat allows, among other functions, blogging, private messaging, group chat, or e-payment. Users and companies can publish dedicated pages on which they can post messages and interact with users. WeChat does not provide a standardized access to its data through API. So the authors developed a dedicated software to crawl the app, which they termed WeChat Scope. The software uses a set of dummy accounts that subscribe to WeChat pages of interest. New URLs posted on these pages are saved and then visited and scraped hourly, continuously for 48 hours. At each visit of the crawler, the sites pointed to by the URLs are scraped and metadata and media content downloaded and saved in a database. If a page disappears, the software saves the official reason for removal given by the platform. The reason content violation is given in cases where content is deemed a violation of related law and regulation. For the study, Yun Tai and Qinghua Fu collected 818,393 public articles on WeChat that were published between 1st of March and the 31st of October 2018 by 2,560 public accounts. Of those, 2,345 articles were removed for content violation. These articles are what the authors are interested in. More precisely, they're interested in how these articles, censored by Chinese regulators, differed from others. In order to do so, they first decided to pair each censored article with a non-censored article posted on the same account that topically was as similar as possible to the censored article. To identify those pairs of censored, not censored articles, the authors ran correlated topic models, CTM. This left them with 2,280 pairs of articles published on 751 accounts. To identify the potentially minute differences between articles that led to censorship, the authors used a random forest model. The approach is well suited for identifying meaningful signals in large numbers of input variables. Using textual terms to predict censorship decisions, the authors identified perilous words, terms whose appearance was more frequent in censored articles than remaining articles. They further differentiated between general terms and those that were unique identifiers of entities, such as place names or organizations, times, or quantities. They found that these specific terms were especially perilous, increasing the probability for the censorship of articles considerably. The authors go on and add to this analysis in further steps, but for our purposes, we've seen enough. So let's stop here. The authors connect this very specific finding to literature on conflict, multi-party games, and coordination. Based on the considerations from these theoretical literatures, they conclude that Chinese censorship reacts strongly and negatively to specific terms, as those might serve as focal points for subsequent coordination or mobilization of users. Thus, not only ideas are suppressed, but also the linguistic signifiers allowing for coordination of people around specific causes or places. The study of government censorship is a continuously moving target, as it remains the hare and hedgehog race between the censor and the censored. The study by Yuntai and Qinghua Fu is therefore surely not the final word on internet censorship or Chinese censorship. Still, their study provides an important puzzle piece in this debate. More important for us, their study provides a highly creative and instructive example of how to use data collected on digital media for the study of speech and government control. Further, it is also an interesting case of how to connect the highly specific and often abstract results from computational text analysis with more general theoretical debates in the social sciences. All the more reason for you to read the study yourself. But sometimes we want not only to learn about what happens in digital communication environments. Sometimes we want to learn about the world beyond. Digital trace data can help us also in the pursuit of these questions. But we need to be a little more careful in reading them in order not to be misled. A look at studies using digital trace data trying to learn about public opinion is instructive in this case. Many people use social media to comment publicly about their views about politics or comment on the news of the day. Taking these messages and trying to learn about public opinion could be a good idea. But right from the start, there are some obvious concerns. First, not everybody uses social media, and those who do differ from the public at large. Also, not everybody who uses social media posts publicly about politics or news. So, we are left with an even smaller, potentially even more skewed section of the public whose public messages we base our estimate of public opinion on. Second, public posts on politics and the news are public. This might seem like a truism, but it is a problem for studying public opinion. Many people hold opinions about politics and the news, but only a very politically active and dedicated person will post those publicly, especially in the case of political controversy. By publicly commenting about politics on social media, people demonstrate their political allegiances and convictions for all the world to see. This includes family, friends, colleagues, competitors, and political opponents. Everyone can see what they think about politics and are invited to comment, silently judge, or to screenshot. Third, not only academics are turning to social media to learn about public opinion. For example, journalists, politicians, and campaign organizers are all watching trends and dynamics on social media closely to get a better sense of what the public thinks or is worried about. Well, we might worry about the power they give social media to influence their actions or thinking, given the biases listed above, but this will not make them stop doing it. So anyone publicly posting about politics might not be doing this to express their honest and true opinion. Instead, they might be doing it tactically to influence the way journalists or politicians see the world and evaluate which topics to emphasize or which positions to give up. As a consequence, studying public opinion based on public social media messages means studying comments, links, and interactions by a highly involved, potentially partisan, non-representative group of people, a portion of whom might be posting tactically in order to influence news coverage or power dynamics within political factions. Anyone looking at these obstacles and still thinking social media posts might be a good way to learn about political opinion truly must be fearless. But as it turns out, there are many who try to do just that. Could it be that they are right? In joint work, Harald Schön, Oliver Posegger, Pascal Jürgens and I decided to check what public Twitter messages can tell us about public opinion and what they can't. In the 2017 paper, Digital Trace Data and the Study of Public Opinion, an indicator of attention toward politics rather than political support, we compared Twitter-based metrics with results from public opinion polls. To get access to relevant Twitter messages, we worked with the social media data vendor GNIP. We bought access to all public messages posted during a time span of 3 months preceding Germany's federal election of 2013, containing mentions of 8 prominent parties. Given Twitter's current data access policy, we would probably have simply used the official Twitter API to identify and access relevant messages, but back then that was not possible. As we were only interested in public opinion in Germany, we only considered messages by users who had chosen German as interface language in interacting with Twitter. This choice might underestimate the total number of messages referring to parties in question, but the resulting error should not systematically bias our findings. We then calculated a number of Twitter-based metrics for each party following prior choices by authors trying to infer public opinion during election campaigns based on Twitter. This included the mention count of parties in keywords and hashtags, the number of users posting about parties in keywords or hashtag mentions, the number of positive and negative mentions, and the number of users posting positively or negatively about a party. To identify the sentiment of messages mentioning a party, we used a Twitter convention prevalent in Germany at the time. Users identified a message as being in support or opposition to a party by using its name in a hashtag followed by a plus or a minus sign, e.g. hashtag CDU plus or hashtag CSU minus. This choice might not be replicable across other countries or time, but it is a robust approach to check whether explicitly positively or negatively tagged messages are more strongly connected with public opinion than normal mentions for our case. This variety of considered metrics reflects the challenge in working with digital trace data discussed by Hausen and colleagues. For this, they use the term event data. We might have objective ways to count the events in which users mention political parties in a specific way, but we have to interpret what these events tell us about their intentions or attitudes. Continuing, we then compared our Twitter-based metrics with the vote share of each party on election day and compared the resulting error with that of opinion polls. All chosen Twitter-based metrics are massively worse than estimations based either on the results of the previous federal election in 2009 or polling results. Calculating metrics per day instead of in aggregate shows this error fluctuating strongly over the course of the campaign with no apparent improvement. Again, this finding connects back to the concerns raised by Hausen and colleagues under the term longitudinal data. Mentions of parties happen over a long period before an election. There are no fixed rules by which to decide over which time period to aggregate the mentions to calculate a metric to predict election outcomes. Any choices in this regard are therefore arbitrary. We get a better sense of the nature of political mentions on Twitter by looking at the temporal distribution of party mentions. The number of party mentions spiked in reaction to highly publicized campaign events. People commented on politics in reaction to campaign activities, candidate statements, and media coverage. Twitter mentions were therefore indicative of attention paid to politics by politically vocal Twitter users, but did not allow to infer the public's attitudes or voting intention. The paper thus shows that there's indeed something we can learn about the world by looking at social media. It just might not be everything we tend to be interested in. In the case of Twitter and public opinion, it looks like Twitter data can show us what politically vocal people on Twitter were paying attention to and were reacting to. But it did not allow for the influence of public opinion at large or the prediction of parties' electoral fortunes. Getting this distinction right between what we wish digital trace data to tell us or what other people claim they tell us and what they actually can tell us, giving underlying data-generating processes and their inherent characteristics, is important. Only by addressing this challenge explicitly and transparently will work based on digital trace data mature and achieve greater recognition in the social science mainstream. The 2 studies chosen here offer only a small spotlight into the possibilities in working with digital trace data. As was the case with the examples chosen to illustrate work based on text analysis, there are many other interesting and instructive studies out there. So please, do not stop with the studies discussed here, but read broadly to get a sense of the variety of approaches and opportunities open to you in working with digital trace data. Computational social science offers us new ways to learn about the world. New data sources emerge, either made available through digitization or bursting into existence through digitalization. New computational methods become available to social scientists, and people coming from different interdisciplinary backgrounds develop new interests in social phenomena and human behavior. This makes CSS into a promising interdisciplinary area, a space of crossroads for people who share interest in social phenomena and human behavior, and where people from different scientific backgrounds meet. Thus, it comes at no surprise that CSS comes in many names and has many relations. Some think of it in topical subfields, such as computational communication science, CCS, data science, or sociophysics. Others think of it not as a field, but primarily see it through associated methods, such as agent-based modeling, network analysis, or computational text analysis. For others, still, it is simply a subfield of applied computer science concerned with social systems and phenomena. Each of these perspectives comes with specific insight, strengths, and contributions. To many, in fact, to be given appropriate space in this and the last few episodes. Still, there are shared concerns among researchers who develop and test theories or provide systematic descriptions of human, organizational, and institutional behavior through the use of computational methods and practices. Those include facing the conceptual challenges of translating social science theories and interests into computational concepts and operationalizations, connecting new data sources with established theories or interests while remaining open to new phenomena and behavioral patterns, and the integration of practices and workflows from different disciplines in order to capitalize on the new opportunities emerging from interdisciplinary efforts. Every scholar and every interdisciplinary team across the multitude of CSS subfields faces these concerns and challenges to different degrees. There is value in remaining aware of the shared roots, concerns, and challenges of computational social science instead of splintering too early into subfields driven by topical interests or methods. This splintering would risk diluting the collective attention and effort to discussing and working through the challenges of CSS. Computational social science, in all its facets, offers scientists new ways to learn about the world and the impact of digital media on politics and society in particular. True, the emotional response to the incessant interdisciplinary efforts in shaping, contesting, and improving goals, methods, and practices of CSS can suddenly shift from exhilarating to exhausting. For anyone, working in CSS means moving out of their comfort zone of field-specific theories, methods, practices, and workflows. Truly lived scientific interdisciplinarity is challenging, but at the same time it is also exciting and promising. As in every new area of research, work in CSS is characterized by uncertainties. At the same time, however, it is an area that, precisely because of its freshness and the open questions associated with it, brings unbelievable dynamics thematically, theoretically, and methodologically. This makes it, without question, one of the most exciting and rewarding areas of social science today. Emeric Pressburger and Michael Powell said it first and said it best. We hope you will come in. The water's fine. That's it for now. And that's it for this week. In our next episode, we will shift our focus from computational social science and questions of method back to substantive questions. In the next episodes, we will discuss artificial intelligence and its impact on politics. As always, the script to this episode can be found online on the course website, digitalmedia.andreasjungherr.de. There, you will find detailed sources, references to further reading, links, and preparatory questions for the exam. This was Tech and Politics, the podcast of the Chair for the Governance of Complex and Innovative Technological Systems at the University of Bamberg. I'm Andreas Jungherr. Have fun reading and see you soon.